We have a variable for education, years of schooling, experience, I'm assuming it's years, whether they're a man or a woman. The name of the variable is the name of the call. It's labeled female. Conventionally, it's 1 if it's a woman, 1 if it's female. Column E is titled union. So if the individual, like person on row 6, the 5th person, is in the union, so they get a 1. The first 4 individuals in the data set are not in a union. So we might use data like this to look at the gender gap. So we can sort the data. So we can sort the data by female or not, right? Then we can go through and do that whole t-test routine. So we can go over here to data analysis. Go over here to our 2-sample t-test, assuming equal variance. We can go through this whole routine, right? We want to go through this routine real quick?
Yes.
So let's go through this routine. For variable 1, I'm going to pick the wages of the women. Variable 2, I'm not going to highlight it. I simply know it's going to be row 2 through row 285, right? What's the hypothesized difference we're going to think of? What's our null hypothesis for the difference? We're going to say it's 0, that they're equal. But we can pick our alpha if we want. 0.05 comes pre-programmed for the convention. We're going to pick our output range. Scroll back up. Let's stick this at the top. Press OK. Variable 1 is female. Variable 2 is male. According to the data, women are earning $2.34 less than men. If we look at our p-values, we see there's a bunch of decimal places, but they're very, very small. It's high, this difference is highly significant. Let's look at the regression method again. Let's use a regression. Let's define our, let's highlight the entire first column of our hourly wage. Let's highlight our female variable in its entirety. We click labels this time. Let's give it an output range over here. Press OK. Now let's go over. Let's look at the R squared. Let's go down. We get the same $2.34 deficiency in the hourly wage of the women as as we did over here when we did the 2-sample test, right? Our t-stat is minus 5.6. It's the exact same t-stat from our 2-sample pooled t-test. And we have our and our p-value is the same as our p-value from our two-tailed test. What else do we have? Do we have all the determinants for wage? No. So let's see what happens when we add in other stuff. All right, I'm going to change the regression. It's going to, you hit regression again, it's going to leave everything you had the first time. It's going to leave it populated. We're not changing the dependent variable here, so we're going to leave it alone. All I'm going to change is the x variables, the independent variables. So let's add education and experience. Makes sense. Keep our female variable in, and let's add union. It makes sense? Collective bargaining, if it's working properly, it's giving people higher wages. Is that a normative or a positive statement? If the union's working properly, it's giving people higher wages.
Depends on which side you're on.
It's positive. It's a positive statement. Given a union, you'd expect the wage to be higher. That's a positive. It has nothing to do with whether or not you think it should be the case, whether you think someone should have unions. Normative statement is unions are good because they give higher wage. A positive statement is the objective result. People mix normative and positive economics in arguments all the time. Okay, anyways, I digress. Let's pick our, where we want to stick this. Let's put this over here. Let's put it right below. All right, we went from explaining with just the female variable alone, a little less than 6% of the variation in wage. We're now explaining just over 30%. We're explaining a lot more of the wage differences among these individuals. So what do you think is going to happen to the coefficient for female? The magnitude of the coefficient, I would expect to go down because other variables that determine wage, or other variables that would cause wage to be higher, like more education, being in a union, are now added.
Not much. Not that much?
Went down a little bit. Is it still significant? Yes. Yes. So when you hear people talk about the gender gap in wages, and then you hear other people say, well, you're not including other variables, you can say, but if you did, your conclusion might be about the same. There's a gap. It's statistically significant. It has meaning. Now we get to the normative issue of, should we do something about it? This is how, if we get a gender discrimination case, if you're working for a lawyer, you'll collect data and you'll do this with public use data sets. And you go to court with results similar to this to demonstrate gaps like this, whether it be gender or race. Did the union work? People in unions make about $1.50 an hour more.
It's pretty good.
It's significant. What does an extra year of schooling do for your hourly wage? Hmm?
Gives you about $1.
Gives you about $1.
Is that more than what you would have without that school?
Hmm?
In this instance, is that $1 more than you would have without that schooling?
Well, we also have experience in here. Experience alone, according to this model, adds 11 cents. Having that extra year of experience. So, if you had to choose, if you're 18 years old and you have to choose going to work right away or going to college for 4 years, what are you going to pick?
Join union.
Join the union. Jokes aside, I mean, if you're 18 years old,
for this industry, whatever it is,
for this sample, whatever this industry might be,
because everyone's different.
That's $4 an hour for a degree.
And union.
It's almost 10 grand a year. That's huge.
it's significant.
Mm-hmm.
But it better be a union job.
Yeah.
Any questions on how we run these regressions? Any questions at all? Any questions about next week?
The homework, we have to do that.
Basically,